Hi, class. Welcome to our chapter 12 on micronutrient function in energy metabolism. I hope you enjoy this chapter today. So, a lot of what we're going to be talking about is the B vitamins, and the B vitamins play a very important role as coenzymes or cofactors, essential to enzymes and allowing enzymes to work, essential to an inactive enzyme and allowing that enzyme to be active. Symptoms of B vitamin deficiency occur throughout the body, and that is because the B vitamins are used in so many different things. The B vitamins are important in metabolically active cells, so cells that are rapidly turning over, such as the skin and the GI tract, and all of our cells are commonly replaced. So the B vitamins are very, very important. Here you see a picture of broccoli in a steamer, and steaming is a good way to preserve the B vitamins because steaming cooks very quickly and the broccoli is not directly touching the water. Remember that the B vitamins are water soluble, and so having them boiled, for example, could cause a lot of B vitamin loss. All right, so generally speaking, most people in North America do have adequate levels of the B vitamins. Um, All right, so in the United States, many of our breakfast cereals are fortified with B vitamins. This is good and bad. I say it's bad because if we didn't process our grains, they would be naturally rich in some of these B vitamins. However, it's good because at least we do add them back. And cereals are such an important kind of staple to our culture that many people eat cereals, and it's a good way for people to get a daily dose of the B vitamins. Worldwide deficiencies are pretty common and do occur in developing countries. And like I said, we don't usually see deficiency in the US, but it is possible. One of the big areas that we see deficiency, which you're going to hear about on just about all of these vitamins, is in alcoholism, because people who are alcoholic often have kind of nutrient poor diets, as well as the alcohol itself can inhibit absorption of these vitamins. All right. So I was talking about the cereals and the processing, and I was saying this is kind of a good and the bad thing. It is good we add vitamins back. However, if we used whole grains, that would be better. And I put all these B's here so that you can remember that whole grains are a good source of the B vitamins. When we process grains, we remove the germ, the bran, and the husk part, and what's left is the starchy part of the grain. And the starchy part does not contain as many vitamins and minerals as the germ, the bran, and the husk. It also doesn't have the fiber. So what do? We add them back, which is better than not adding them at all, but yeah, we add them back. And so we add back many of these B vitamins. However, they still can be lower than what they would be if we used the whole grains. So the very first B vitamin we're going to talk about is B1, and this is the first B vitamin discovered. All of the B vitamins do play a role in metabolism and energy release, and so that will be a common trend throughout this presentation. Thiamine plays a role in the enzyme thiamine pyrophosphate, or TPP, and this helps with ATP producing pathways that break down carbs and amino acids. Thiamine is also important in reactions that make RNA, DNA, and neurotransmitters. So pretty important to our whole body. I mean, ATP, DNA, RNA, and neurotransmitters are crucial to life. In thiamine deficiency, there is a disease called beriberi, and it comes from the Sri Lankan word for I can't. And this is because when people have thiamine deficiency, they feel so sick and so weak that they literally can't do anything. Some of the symptoms include low appetite, irritability, tingling, poor arm and leg coordination. That's where the I can't comes from, deep muscle pain, and you can see rashes on the face and the hands and the legs. Symptoms can start occurring in as little as 10 days. especially if somebody's drinking alcohol. And this deficiency was discovered before we actually knew what vitamins were. We started to see these signs and symptoms in countries where they ate a lot of polished rice. And polished rice is white rice that has been processed, so all of those healthy parts of the rice are removed. Why is this such a big deal? Well, when we don't have any thiamine, we cannot metabolize glucose, and our brain cells and nerve cells have to rely on other sources of energy. Some sources of thiamine are in this chart here. You see purple is protein foods, orange is grain foods, green is vegetable foods, and you even have some dairy and fruit. So there are quite a lot of food sources of this. Most men exceed their needs and most women meet their needs. Here's the RDA. I won't have you memorize RDAs, but I do think it's important to know trends, like if they increase with age or if they decrease with age or if there are ULs. And who might be deficient. So sometimes people who are low income or the elderly, also alcoholics, anyone who's eating a poor diet, very rich in processed foods, might be deficient as well. Next, B vitamin, vitamin B2, riboflavin. So riboflavin comes from the word flavus, which means yellow in Latin. And so riboflavin is actually kind of a yellow pigment. And riboflavin plays a role as the coenzymes FAD and FMN for energy yielding pathways, such as amino acid breakdown and fatty acid breakdown. It is also important to vitamin and mineral metabolism, and it plays an indirect antioxidant role by supporting the enzyme glutathione peroxidase. Riboflavinosis is the name of a deficiency that can occur if you do not have enough riboflavin. And here you can see swelling and redness of the tongue, cracking of the corners of the mouth. Dermatitis is a skin inflammation, eye disorders, sun sensitivity, which can make these skin conditions worse, and confusion. And this often occurs in combination with other vitamins such as B6 or B12. Some sources of riboflavin are listed here. You see grains, dairy, and protein being pretty high in riboflavin. And there is no upper limit for riboflavin. People with poor diets as well as alcoholics do sometimes have low riboflavin intakes. Riboflavin is sensitive to light, and riboflavin is found in dairy products. And so because it is sensitive to light, dairy products are packaged in cardboard or opaque containers so that that riboflavin won't be destroyed. And because dairy is pretty predominant in our Western diet, many people do meet their riboflavin needs. Our next B vitamin, niacin, B3. Niacin functions as one of two related compounds, either nicotinic acid or nicotinamide, and it's very important for ATP generation. It's an enzyme in over 200 metabolic reactions, including when we're burning carbs and fat and many anaerobic pathways that are important to form new compounds, for example, fatty acids. Niacin deficiency is called pellagra, and deficiency causes widespread problems because it functions in so many of those enzyme reactions, over 200. And so the deficiency causes widespread problems throughout the entire body. Deficiency can be remembered by the 4 Ds, and these are dementia, diarrhea, dermatitis, and death. Death would obviously be a very severe effect of deficiency, but it is possible. In the United States, we have seen deficiency of niacin, and this happened between the 1800s and the 1930s in the South, where people were eating diets that were very low in niacin. They were eating corn. However, in corn, niacin is bound, and so we can't use the niacin that's in corn unless it's been treated or soaked. Many Hispanic Americans or Hispanics do soak their corn in a lime water, and that helps free up the niacin. And so you actually see low levels of niacin deficiency in cultures that soak their corn before using it. Sources of niacin, you see primarily purple up here. Remember, purple is protein foods. You also do see some vegetables, mushrooms, potatoes, and some grains, because this could potentially be added to cereals as well as occurring in tortillas. Niacin recommendations. The RDA for niacin is expressed as niacin equivalents, and this is because we can get niacin from food sources, as we saw in the previous slide, or we can actually synthesize our own niacin from the amino acid tryptophan. And it takes about 60 milligrams of tryptophan to make 1 milligram of niacin. We're able to meet 50% of our niacin needs just through this synthesis pathway. However, in order to synthesize it, we obviously need adequate tryptophan, and we also need riboflavin and B6. Most Americans do meet their recommendations for niacin. And like we said, food sources are good, protein foods, but also coffee, tea, cereal, and asparagus. And only a small amount is lost during the cooking process. What if we have too much niacin? So some people might take niacin supplements to try to treat cardiovascular disease, and some people may even be prescribed niacin supplements to treat cardiovascular disease, because niacin can play a role in lowering our LDL cholesterol. However, this can have a flushing effect, where somebody's face will literally turn kind of red and they'll feel kind of hotness and just very kind of flushed, some of the small vessels in their face will dilate. And this doesn't do permanent harm, the flushing itself, but it can be kind of uncomfortable and look a little bit weird. Additionally, too much niacin can cause headache or itching, but it can also cause liver or GI, gastrointestinal damage, which would be more harmful in a long-term setting. If somebody is going to use large doses of niacin, or if a doctor is prescribing a large dose of niacin, it's recommended that that person is monitored very closely. Pantothenic acid, B5. So pantothenic acid is very important. It's needed for synthesis of coenzyme A. And remember, we need coenzyme A as part of our citric acid cycle. We would not be able to complete that citric acid cycle without this coenzyme A. Pantothenic acid also activates fatty acids so that they can yield energy and plays a role in fatty acid synthesis. There is no upper limit, and we don't know about toxicity of this particular vitamin, and we do see deficiency in alcohol, so that's a big trend with these B vitamins. Some sources of pantothenic acid: corn flakes, Power Bar, Luna Bar, sunflower seeds, beef liver. You've got some vegetables, some dairy, some protein foods, and some grains there. Pyridoxine, B6. So pyridoxine is actually a family of 3 similar compounds, and they can be converted into the B6 coenzyme PLP, or pyridoxal phosphate. It plays a role in over 100 reactions, so it's very, very important, and it helps with metabolism of carbs, protein, and lipids, as well as synthesis of non-essential amino acids, serotonin, a very important neurotransmitter, and important for heme and red blood cell metabolism. It helps with the synthesis of the heme portion of hemoglobin, which is what carries the oxygen. B6 deficiency. So deficiency can affect the body in many areas because it plays a role in so many reactions. Symptoms may include depression, vomiting, anemia, impaired immune response, and skin disorders. It is common in alcoholism, again, because alcohol decreases the absorption as well as decreases the synthesis of its coenzyme form. Sources of B6. So here we've got quite a variety of foods. We've got some protein foods, some fruits, specifically banana, vegetables, watermelon, some grains, just quite a variety of foods where you can find B6. Daily recommendations. Most people are getting plenty of B6 above the RDA. Certain populations who may need more are athletes, and this is because in athletes they are having higher levels of glycogen and protein metabolism, and so B6 is a required vitamin for both of those processes. This is heat unstable, and so heating and freezing can destroy it. However, I've looked about freezing, and the extent is not quite as significant as heating is, but both of those factors could play a role. This is why eating fresh fruits, fresh veggies, fresh proteins, fresh grains could be important. Too much B6. Is there an upper limit? Well, there is an upper limit. So that means that too much B6 could be a problem. It can actually cause irreversible nerve damage, and this can happen in just 2 months of taking too much B6. It could also cause problems walking. It could cause problems with tingling or numbness. B7, biotin. So another important coenzyme. This one doesn't play a role in as many reactions, not 100, not 200, more like a dozen. However, these are still very important reactions, such as making glucose and fatty acids. Deficiency of biotin, you can see some of the symptoms there. Some of those symptoms overlap with some of the other B vitamins that we've seen. Sources of biotin. Here you have a lot of protein foods, some dairy, some grains, and a little bit in cauliflower. These pictures, I will say, these sources from your book, these are not all extensive. That doesn't mean that these foods listed are the only foods where we can get these vitamins. There are others. This is just trying to give you an overview. Recommendations for biotin. So most diets do meet adequate levels of biotin. We just have an adequate intake level. We don't have an RDA. We also don't have an upper limit because it's relatively non-toxic. And bacteria in our bodies can actually make us biotin. Deficiency is pretty unlikely unless somebody has been on antibiotics for a long time and those healthy bacteria that make the biotin have been killed off, or potentially if somebody has had surgery to their large intestine with a large part of it removed, or potentially if they were eating a lot of raw eggs, because a protein in raw eggs can actually bind to biotin and destroy it. Iodine. So we're moving away from the B vitamins and talking about some other important components for metabolism. Iodine is very important for metabolism, and it is utilized by the thyroid gland. There is a small little typo here. I apologize. This should say thyroid, not thyroid. And it's used to make the thyroid hormones, which are absolutely crucial for life. Plants get iodine from the soils. So in areas where the soils are rich in iodine, plants have plenty of iodine, then we eat the plants, or animals eat the plants and we eat the animals. In areas where there's low levels of iodine in the soil, iodine deficiency can occur. And we recognize this, so we have started adding iodine to salt because it's relatively tasteless in salt, and salt is so prevalent in our diets that this is a good way for us to get adequate amounts. What happens in iodine deficiency? So if iodine deficiency, or if iodine is low, the thyroid tries to take up more from the bloodstream. I see another typo. I'm sorry, you guys. To take up more from the bloodstream. I thought I fixed these. And this can lead to a goiter. So here you see a goiter down in the bottom. If somebody is deficient during pregnancy, then it can lead to something called cretinism in the baby, and this would be a baby who has short stature, as well as some facial kind of abnormalities, as well as some developmental delays. This is a relatively common deficiency globally, and it's estimated that over 2 million people are affected, with iodine deficiency still being common in some of these countries listed here at the bottom. All right, some sources of iodine. So iodized salt, like I mentioned, some fishes, some dairy products, some fortified bars like breakfast bars and Luna bars, eggs, and also it's pretty high in seaweed. So we're going to talk about seaweed coming up. RDA is 150 micrograms per day, and most people get enough. However, it's possible that vegans could be low. Also, if people are using sea salt or kosher salt, these do not contain iodine because iodine's been lost during processing. If people eat a lot of seaweed or take a lot of iodine supplements, it is possible that they could get too much. Seaweed has approximately 1% iodine by weight, and so it is a very, very high source of iodine in the diet. Chromium. So chromium is something that is required for glucose uptake in the cells, and it's essential to insulin function. Without it, we have impaired glucose control, high blood cholesterol, high triglycerides, increased risk for type 2 diabetes. And chromium absorption from foods is pretty low. It's estimated that we only absorb about 0.4 to 2.5%. The rest of the chromium is excreted mostly in our feces. So what are the recommendations? Adequate intakes 25 to 35 micrograms per day. Most of us get something right in the middle of that. There is no upper limit because there's not a toxicity. We don't see toxic issues with this. And it can be affected by manufacturing. Usually that means lower levels. However, it is also possible to be a contaminant, so that could cause it to be higher levels. But there's not a UL, so we're not really concerned. Manganese and molybdenum, also important to metabolism, but I'm going to let you read about those on your own. And then choline. Choline is a pretty interesting one because it's not classified as a vitamin yet, but in 1998 it was recognized as something that is essential for our health, and it plays many, many roles that we're going to learn about. Some good sources are milk and dairy, and there are additional sources as well. You see a pregnant woman here because it's especially important for pregnancy. Choline plays a role in cell membrane structure. Remember, all cells have phospholipids as part of their structure, and choline is actually a precursor to those phospholipids. So without choline, you would not be able to form that phospholipid cell structure. Choline is important for nerve function and brain development, specifically during pregnancy for that developing fetus, and it's also important for lipid transport. Some sources of choline. Here we have eggs, chicken, cod, milk, beef, yogurt, tofu, broccoli, squash, quite a few sources. There are different recommendations for men and women as well as for pregnancy. And generally speaking, prenatal vitamins don't have choline in them. I know when I was pregnant, I was not able to find one that contained choline, so I ended up buying a second supplement that did have choline in it. I didn't feel that I ate enough of the food sources of choline. However, I do have more variety of choline now. We are able to synthesize some of our own choline, but that requires adequate choline and methionine levels. So it's possible that we wouldn't be able to make it if those were lacking. Some of the benefits, it's possible that it can reduce birth defects. In studies, they've shown that babies who were born to women with low choline intakes had 4 times as many birth defects as babies born to women with high choline intakes. However, The catch-22 is if you take too much, it may promote cardiovascular disease. So that could be an issue. Conclusions. So we talked about many B vitamins today. We also talked about iodine, chromium, manganese, molybdenum, and choline, all important for metabolism. So I hope you enjoyed this chapter, and I will see you next time.